Hey Algebra students, here is the second part of your review for second semester final. We start off with factoring, 8.9. Here we've got a regular standard trinomial quadratic. You guys did really well on this on your milepost test. So we want to find factors of 50 that would add up to 5. Well, you know that you need to have one positive and one negative. That's the only way when we multiply these back together we get a negative 50. And then 10 minus 5 gets me positive 5. Now don't leave it there because I'm asking you to solve, not just factor. And so what values for t make this equal to 0? We use the zero product property again. When t equals negative 10, that makes this equal to 0. When t equals positive 5, that makes this equal to 0. So those are my two solutions. All right, 8.11, factoring with an a value. Well, here, you can use guess and check if you'd like, or you can do mathemagic one more time. I take the a value multiplied by the c value, and that turns it into just one of those regular ones, like this one up here. Something that hopefully I can factor, and in fact I can. I got a negative, so one positive, one negative. Factors of 12, that would give me positive 11, be positive 12 minus 1. But don't forget, if I multiply it in by 3, I have to divide out by 3. If I can divide and get a whole number, then I do it. 12 divided by 3 is 4. If I cannot divide and get a whole number, I take that denominator and slide it in front of the x. So I get 3x minus 1. Now again, I've been asked to solve, and so what values for x make these equal to 0? Because remember, this is all still equal to 0. Well, this one over here, that's pretty easy. When x equals negative 4, that makes it equal to 0. But over here, what value of x makes this equal to 0? Well, I can actually just pop right up here and find that x equals 1/3. When 1/3, or x equals 1/3, 1/3 minus 1/3 is 0. And so that's my other solution. 9.1, you're just doing a little graphing along the y-axis. And so you've got negative 4. That means you're going to take that vertex of the parent function, just shoot it down 4 spots. And then your a value is 2. And so if my a value is 2, that's going to make it more narrow. How narrow? Well, we would just graph y equals 2x squared, pretending like this is the origin, and go from there. So when x equals 1, 1 squared is 2. Or sorry, 1 squared is 1, 1 times 2 is 2, so I go over 1 up 2, and I got the symmetric point over here. Probably want one more just to be safe. 2 squared is 4, 4 times 2 is 8, so I'd go over 2 and up 8. And there's my function. And of course my comparison, this goes down, and it's more narrow than the parent function. All right, now I've got a graph using the axis of symmetry. Well, hopefully you remember that the axis of symmetry is found by that formula negative b over 2a that we discovered in class. So if I've got b is 4 and a is negative 2, that gives me negative 4 divided by 2 times negative 2, which would wind up being 1. And, well, that's nice. That gives me an axis of symmetry of 1, but now I need to find the vertex. I'm going to plug in the x value into my original equation, and that will find me the y value on my axis of symmetry. So I plug in 1. 1 squared is 1. 1 times negative 2 is negative 2. 4 times 1 is 4. Remember, this is always going to be double this and then opposite the sign. And I got the negative 3 out here. Negative 2 plus 4 minus 3 gives me 2 minus 3, which is negative 1. So my vertex is at 1. This one winds up being real nice because this is my y-intercept, the c value. And so I've got a point right here at negative 3 on the y-intercept. I've got a symmetric point on the other side of the axis of symmetry, and now I've got enough to graph. Okay, over here you're going to solve the equation by graphing, which means you actually need an answer, x equals. It's not a function like this one. It's an equation that you need to solve. And so, basically what I've told you is go ahead and graph using the x-intercepts, because the x-intercepts are going to be your solutions, kind of a hack. And so I just go ahead and solve by factoring here, and I get the answer, negative 3 and 2. But of course I need to solve it by graphing, and so I need to make sure I have the graph that matches my answer. So I got negative 3, positive 2. Those are 2 coordinates on my graph. And then you can find the other stuff however you want. I solved or I graphed it by finding the axis of symmetry by taking the x-intercepts and cutting them in half. So -3 plus 2 divided by 2 is -1/2. That's a little unfortunate. It's not a very convenient axis of symmetry, especially when I need to find my vertex. So now I got to plug in -1/2 into the original equation, or I could plug it in here. I chose the original equation to solve for y, and y was -6 1/4. So now I've got that point here, and I can continue making my graph. All right, on to the last section. We start you off with just needing to solve by taking the square root. And so you're just going to use the reverse order of operations. I take care of the addition or subtraction. I subtract 6. From 10 I get 4. Then I take the square root of both sides. That takes care of the square. And don't forget that the square root of 4 is 2 and -2. And then to solve for x, I'm going to subtract 5 from both sides. 2 minus 5 gives me -3. But then also, which is something a lot of you forgot, -2 minus 5 is -7. No algebra final would be complete without the quadratic formula, and here it is. You got -b, so -7 is +7, plus or minus the square root of b squared, -7 squared, minus 4 times a, which is 2, times c, which is -4, and then you take it all divided by 2 times a, which is, again, 2. I find the discriminant. I'm going to do that on my calculator. And all of that winds up equaling 81, which is a good sign. Square root of 81 is 9, and -9. So that's where I start to split it off. I got 7 plus 9 is 16, divided by 4 is 4, and then 7 minus 9 is -2, divided by 4 is -1/2. All right, some of the stuff that we just did recently, permutations, combinations, nothing too tricky here. How many ways can you arrange 4 of the letters of the word Remsburg? Well, you've got 8 letters, and you've got 4 spots to fill. Go ahead and assume that even if you have like multiple letters, we're still rearranging those letters, and they're different. So 8 factorial divided by 8 minus 4 factorial, or you could just do 8p4 in your calculator. I'm not real particular about it. 1,680 ways. And then I see 11.4, that was the combination. So Cade's got 20 smelly socks and 4 clean socks. It means he's got 24 total objects. How many different ways can he pick out his 2 socks? Well, he only has 2 feet, so he needs 2 socks. So groups of 2. 24C2 is 276. The final process standards question here is another quadratic formula one. So you've got the original thing here, the equation that we've used oh so often for height, and your initial velocity is 24, so that's going in for v. You've got the initial height is 1, so that's going in for s. And then determine when the ball would be 8 feet above the ground. Well, that's the height, that's going in for h. So that's where this comes from, and you need to solve this. Well, if you're going to use factoring or quadratic formula, you need to make it equal to 0, so I subtract 8 from both sides. That's an important first step. And even if this was factorable, that would probably be pretty tough. So I'm going to go ahead and use the quadratic formula. I go ahead and do that, and I wind up with 0.4 and 1.1. What does that mean? Well, it means the ball is at a height of 8 feet at 0.4 and 1.1 seconds after being kicked. I put this would be a long pass for this kind of height and time. All right, well, that's it. Good luck studying, and good luck on your final tomorrow.